Let's start. Good afternoon, students. So today we will discuss what is control system, and then after that types of the control system and what is control system. So first of all, control system is a combination of elements arranged in a planned manner. It is a combination of elements arranged in a planned manner. Control system is a combination of elements arranged in a planned manner, whereas each element cause an effect to produce the desired output. Whereas each element produce the effect in desired output. Right? So number of elements are there. Number of elements are there which will be arranged in a planned manner so that we will be able to get desired output. That is called control system. Now there are two types of the control system. In general, there are two types of the control system. One is open loop control system, types of control system, open loop control system, and closed loop control system. Right? So in case of this is your control system. Here we are applying the input and across it we are getting the output. Now see this is the open loop control system. This is the open loop control system in which the output is neither measured nor fed back for comparison with the input. In this case, you may see there will be no feedback element. Whatsoever input we are applying, same we are getting the output in same proportion. I had already taken one example for the iron without any cutoff, without any temperature sensor, right? So in that particular case, what will happen? As far as input is applied, this may cause your temperature of the iron will increase. Till the time we are applying the input, temperature will be increasing. There will be no control over the output. Output is proportional to the input, right? So what will happen in case of open loop control system? In case of open control system, there is no feedback element. Right. Now come to the, this is the diagram for the open loop control system. Now for the closed loop control system, see here I am just taking these notation, then I will explain it to you. Now see here, this is what RS is the input, this is the open control system, and this is the closed loop control system. Right? RS is the input, CS is the output. And here I am taking this negative. Now, this is the, this second diagram represent this diagram represent closed loop control system. This diagram represents closed loop control system. Right? In this, GS is forward path gain. GS is forward path gain. Right? So in this case, this GS represent forward path gain or forward path transfer function. HS is feedback transfer function. Right? And this is a, this represent summing point. RS is the reference input, and CS is the controlled output. These are various notation. Now see here, in this case, at this particular point, there is a signal ES. ES stands for error signal. ES is a error signal. Right? Now, just take an example of air conditioner. Let us say I had just set the temperature of the air conditioner at 20 degrees C. Right? I had just set the temperature at 20 degrees C. And that means 20 degrees C is actual output of the system. Right? 20 degrees C is desired output. And present, as per the present scenario, let us suppose the temperature of the room is 35 degrees C. Right? This is the present output. Now what will happen? 35 minus 20, 15 degree. This is the error signal. Right? 15 degree C is the error signal which will be generated by comparing the desired and actual output. If you compare the desired and actual output, you will find the error signal. So here error signal is generated. At this particular point, error signal is generated. Right? And as per that, feedback is given across the input. Feedback is given across the input. And proportionally supply will change. Let us suppose if your temperature is, if in any case your temperature will reach up to 35 degrees C, then there will be no error. There will be error-free system. So in that case, feedback is 0. And at that time, your compressor will be off. So this is the feedback control system or closed loop control system. Feedback control system or closed loop control system is one of the same thing. Right? And here at this summing point, I am taking this negative sign. So generally, in your communication network, we will prefer negative feedback. We will prefer negative feedback. Why is it so? Because this will just depress your that errors or noise in the system. If we are applying the negative feedback, this may cause your output to be more specious than ordinary. So in case of communication network, we will prefer to use negative feedback. Now, if you compare that open loop system and closed loop system, comparison between the open loop system and closed loop system, right? So here the accuracy of an open loop system depends on the calibration of input, right? Any departure from the predetermined calibration affects the output. That means if your system is not properly calibrated, this may cause more error in the network. But in case of closed loop system, error signal is generated by comparing the controlled output and actual output. So one more thing, that open loop system are generally stable. Open loop system are generally stable, and closed loop system can become unstable under certain condition. There are more chances for the open loop system to be stable, but if you see, in case of closed loop system, there are more chances to be for the system to be unstable, right? The operation of the open loop system is affected due to presence of the non-linearity. And in case of closed loop system, the performance of the closed loop system adjusts to the effects of non-linearities present in its element. We will prefer the system to be closed loop system, right? Now we will just start with the block diagram reduction. Let us say this is your GS, input is RS, and output is CS. Now we know that this GS is equal to, GS is what? Transfer function, Laplace of the output over Laplace of the input. This is already in term of Laplace. So CS upon RS. GS is equal to CS by RS. And then from here, GS is equal to GS into RS. That will be equal to CS. Right? So in this case, this diagram represent only one block is there. Only one block is there, and that will be GS. So here output will be product of the forward path transfer function and this reference input. Then after that, what is takeoff point? Here input is RS, output is CS. So this point, this is called takeoff point. And this is the summing point. Takeoff point and summing point. So takeoff point is a point where that input is applied across the number of function, number of sources. Application of one input source to two or more system is represented by a takeoff point. right? If we want to apply, this one input across the two or more system, then it will be represented by takeoff point. That means across this part RS is there, and across this part again RS is there. Right? Now this type of the connection, that means these are, if you say it in term of resistances, this is called resistance. If here instead of G1S and G2S, if instead of G1S and G2S there are resistances, then these are called resistances in parallel. And here in this case, this is known as blocks in cascade. This type of the system is known as blocks. In this case, if there will be no summing point, then at this point this will be C1S, and here it will be C2S. Right? So input across both of the elements is RS. So G1S, that will be equal to C1S over RS, and G2S is equal to C2S over RS. Right? Now, next is, if across it this will be open, then obviously we are getting the different output. Right? Now, next is, that means if number of signal are joined together, then it is called point. The point where number of signal are joined together, it is called summing points. And if number of signal will be applied across number of system, one signal is applied across number of system, then it is called takeoff point. The next is blocks in cascade. Now let us say here this will be your G1S, G2S, G3S, and input applied is RS, final output is output of the first block is C1S, output of the second block is C2S, and final output is CS. Now if in this case I want to find the total CS by RS, so in first case, from block diagram, G1S is equal to C1S over RS. C1S over RS. From this, C1s is equal to G1s into RS. Now G2s is equal to C2s over C1s, output upon input. From this, C2s is equal to G2s into C1s. Substitute the value of C1 from upper equation. You will get C2s is equal to G2s into G1s into CS. Right? C1s is equal to G1s into RS. Now G3s is equal to CS over C2s. Output, final output is CS. Input to the G3s is C2s. Now from this, CS is equal to G3s into C2s, and substitute the value of C2s from this equation. Right, here it will be RS. So this will become, first substitute this value of C2 from upper equation, and then from that CS by RS is equal to G1s, G2s, G3s. So if blocks are connected in cascade, if n number of the blocks are connected in cascade, that means in series, then the total transfer function of the block diagram, total transfer function of the block diagram is product of all the blocks. Product of all the blocks. Now see here, if there are three blocks G1s, G2s, G3s, then it will be CS upon RS is equal to G1s into G2s into G3s. So if blocks are connected in cascade, its total transfer function that will be given by product of all the blocks. Right, so we are just driving some rules which will be applied for block diagram reduction. Right, this is one of the rule, that if number of blocks are connected in cascade, total transfer function is product of all the blocks. Right, now answer this poll.
Well, so this is the end of the lecture. We will meet in next lecture again. Thank you.